Hello grade 11s and welcome to our session on graphing problems. Now I'm sure you've all read a newspaper and seen that there's many graphs in there, and I wonder if you know how to interpret it. Well, let's get straight into it and review some of the graphs that we commonly get in real life as well as maths literacy. Here we go. First of all, let's find out what we're going to be doing. We're going to be summarizing a couple of key concepts on bar graphs, histograms, pie charts, and line graphs. Let's get going with bar graphs. Bar graphs are used to display discrete data. Now, discrete data is when there cannot be a fraction of the item being studied. For example, peoples, motor cars, or countries. I like to think of it as data that has got no order. For example, if we look at modes of transport to get to school, can you tell me that a taxi comes before a bus or walking comes before driving? No, you can't. Also, can you drive half a person to school? Or can a quarter of a person take a bus? Of course not. That's the way that I remember discrete data. In a bar graph, the length of the bar corresponds with the frequency of the object. For example, how high the bar graph is tells us how many people are in that category. The gap between the bars indicate that each bar represents a separate category. There must be a gap before the first bar too. The width of each bar has to be the same. Let's look at an example. An example of a single bar graph shows a comparison of one type or one group of data. I'm sure you all have cell phones and everyone decides that their cell phone is the best, but how many cell phones does each person, or how many cell phones of each kind are there in the class? So for example, let's look at a grade 11 class. We see that over here there are 7 Nokia phones, 12 Blackberries, and 10 iPhones. Wow, must be a private school. So as you can see, the height of each bar tells us how many people have that type of phone. 7, 12, and over here 10. And just to make sure that you've noticed, each bar is exactly the same width. That's the way it's meant to be. Let's have a look at a compound bar graph, or as I like to call it, a double bar graph, because we're usually comparing two groups of data. If we have a look at this example, we're comparing the number of boys and girls in each grade. So we're comparing two different things, the number of people in each grade and then the number of boys and girls in each grade. So if you have a look over here, girls, we've got the darker bar in each case, and boys, we've got the lighter bar. So in this school, you can see that there are more boys. Now I've done this a little bit the wrong way around. I've done pink for boys and green for girls, but that doesn't matter. There are more boys in grade 8, whereas in grade 9, there are very few boys and many more girls. In grade 10, just a few less boys than girls, and in grade 11, we're exactly even, and in grade 12, well, there's more boys than girls. So can you see how we're comparing boys and girls as well as the number per grade? Here's a different way to represent compound bar graphs. Instead of the bars being side by side, like they are in this example, over here, the bars are one on top of each other. And I'm going to do the same as last time. Boys in pink and girls in green. Now this one gives us a better representation of the people all together in the grade. They're between 70 and 80 grade 8s. But then when it comes to working out how many boys there are, we have to find this amount over here, and we're going to have to say 75 minus 33 or so that the girls are, and we get the number of boys. Whereas in our double bar graph, which is side by side, it's a lot easier to find out how many boys there are and how many girls there are, but it's not as easy to see how many people there are in total for the grade. So that's our two different ways of representing bar graphs. Now let's have a look at histograms. Histograms are a way to display continuous data. Do you know what continuous data is? Well, over here it says continuous data is when there can be a fraction of the item being studied. For example, growth in a year, speed of a vehicle. A histogram can also be used to display data that's grouped into intervals. Let me give you an example of that. Let's say, for example, we're looking at the marks of a class test and we're looking at percentages. Now, it would be stupid to say 1%, 2%, 3%, 4%, all the way up to 100% and look at our values like that. Instead, it would be much easier to group our data. How many kids got between 0 and 9%, 10 and 19%, 20 and 29%? So can you see that grouping data also allows us to analyze it a little bit more carefully? With that, we use a histogram. Another way that I like to remember histograms when we use histograms is that our data has to be in an order. For example, let's go back to our percentages. We're not going to compare, well, who got 80%, who got 30%, who got 70%. We'd like to do it in an order, from smallest to biggest. So we start with our smallest group and go all the way to our biggest group. In a histogram, the length of the bar corresponds with the frequency, just like our bar graph. How many people got that mark? That is how high our bar should be. There's no gap between the bars, except, of course, a gap in the first instance. The width of the bar has to be the same each and every time. Let's have a look at an example. For example, the marks of a test. As you can see over here, we've got kids who got 0 to 29. Well, there were 5 people. Over here, 30 to 39. There were 3. 40 to 49. There were 6. 50 to 59. 7. 60 to 69. 8. 70 to 79. There were 6, 5, and 4. So this shows us very clearly where the marks were distributed in the class. Who got the best marks? Well, 90 to 100% got the best marks. But which category had the most people? Well, it was the people who were between 60 and 69%. Let's have a look at the next thing. Let's have a look at pie charts. A pie chart is useful in showing a comparison of how the whole is divided into different categories. The relative size of each piece of the pie represents the percentage of the whole that the specific category occupies. Percentage, that's a very important word when looking at pie charts. For example, a comparison of the number of males and females in your school. Well, are there more boys or are there more girls? A pie chart would be able to show us if, for example, there are 55% girls and 45% boys. It'll show us the relative sizes of each and give us a better idea. Let's have a look at an example. A grade 11 class conducts a survey about learners' favorite drinks from their tuck shop. They summarize the data as follows. Well, we've got Coke. 9 people preferred Coke. We've got Fanta. 4 people preferred Fanta. Sprite, water, Coke Light, and fruit juice. Out of all of these options, which one was the most popular, and can we compare to the total amount of people which one was more popular? So first of all, what you need to do is you need to calculate the percentage. Convert your frequency into a fraction of the whole and multiply by 100. Let me do an example for Coke. Coke, we've got 9 people that prefer Coke. And it is out of a total of 35 people who completed my survey. And to turn this into a percentage, we multiply by 100 to get our percentage. And let us have a look over here. We've got Coke, and it was 26%. Obviously, it's very popular. If we convert all of our other numbers into percentages, we'll be able to tell what was the most popular and what was the least popular. In this example, fruit juice is the least popular at 9%, and Coke is the most popular at 26%. Can you see how each category shares a part of the pie? I hope you can see. Let's move on to line graphs. Line graphs show continuous data. It shows the relation between the dependent variable and the independent variable. The dependent variable is always shown on the y-axis, and the independent variable is always shown on the x-axis. These graphs are useful when trying to see the trends in the data. The points are plotted on the graph, and then a line is drawn to show if our trend is positive or negative, or just not changing at all. It's important to note that only the points plotted are accurate. We can sometimes extrapolate, but unless we have an actual point, we can't say exactly what the point of the data is. Let's have a look at an example. Over here we're looking at enrollment figures for the past 5 years. Perhaps it's the enrollment into schools? I think so. Over here it shows what has happened in 2006, 2007, 2008, 2009, and 2010. And as you can see, they haven't done it here, but each point is plotted and the points are joined to show a trend. The trend in this case is an increasing trend. The line is going up to show that every year more and more people enroll. Let's have a look at some examples. Let's have a look at question 1. We get given a double bar graph and we're going to be asked to answer some questions about it. First of all, let's make sure we know what this double bar graph is telling us. It's telling us the percentage distribution of population aged 20 years and older by the highest level of education. So none of you in grade 11 are older than 20 years, I hope. So this wouldn't pertain to you, but maybe your parents have got a matric. They would fall in this category. Some of you might know somebody who hasn't done their high school at all, and they've only completed some primary school. They would fall into this category. And of course, people who've had no schooling at all would fall into this category. We get given a second bar graph, and this data has come from our census 2001 and census 2007. Unfortunately yet, the 2011 census hasn't been completed, so we don't have data from that, but I'm sure we'll be getting it in a couple of years' time. Let's have a look at this. Percentage of households with household goods in working order. So we have a radio, a TV, computer, fridge, landline telephone, internet, and cell phone. And as we can see, the double bar graph shows the progression from census 2001 to census 2007. And as you can see, in most cases, the people with the radio has gone up. The amount of televisions in homes have gone up. Computers up, refrigerators up, landline telephones, now this is an interesting one, it's gone down. But I think we can notice that it's gone down because the amount of cell phones has gone up substantially. Let's have a look at the questions. Comment on the graph showing the distribution of education amongst the population aged 20 years and older. Substantiate your answer by including percentages. Right, so the question is asking us just to comment on the graph. I would like you to notice a couple of things, and let's do this together. First of all, can we say that the overall amount of schooling has increased? And I would say yes, by looking at this over here. And let's make sure that we've got the right thing. The bottom one is 2001 and the top one is 2007. So from 2001 to 2007, the amount of people that had no schooling at all has decreased. This is fantastic. It means that people who are completely illiterate have decreased. So we can say here, no schooling has decreased from, what was it? 17.9% to 10.3%. And this is a very good thing. Right. We can comment a little bit more on others. Let's look at higher education. Higher education from 2001 to 2007 has increased. And for this question, you might like to write a sentence that says, the amount of people over 20 who have a higher education degree has become more from 2001 to 2007. Let's have a look at others. From 2001 to 2007, the amount of people getting a grade 12, a matric, has decreased. Wow, this isn't necessarily a bad thing, because we could say, well, instead of people having a matric, they've now gone on to get a higher degree. That's why the amount of people getting matric has decreased. A very big increase is in our some secondary. As you can see, from 2001 to 2007, we've had a massive increase of almost 10%, from 30.8 to 40.1%. Let's write that down. Some secondary has had a big increase from around about 30% to around about 40%. That is a very big increase, an increase of almost 10%. Let's have a look at the next question. B. In the 2007 census, the number of people in this particular area that had received primary school education was 8,000. Determine the number of people that didn't receive any schooling at all in 2007. Well, this is one number to look at, 8,000, and the second thing to look at is primary school education. So over here, we have got completed primary, and we were looking at 2007, so the amount of people that completed primary was 5.9%. So we know that 5.9% was equal to 8,000 people. How are we going to work this out? Let us see what amount of people is equal to 1%, and then multiply that by a percentage of people that did not receive any schooling at all in 2007. So let's quickly get that figure. So no schooling at all in 2007, it was 10.3%. And I'm going to write that over here for future reference. All right. So to get what 1% is, we can say 8,000 people divided by 5.9, and that will give us 1% of the population. So let's have a look at our calculator. We're going to say 8,000 people divided by 5.9, and then To get it up, we will have our answer in what is equal to 1%. And if we want to get something up from 1% to 10.3%, we just have to then multiply our answer by 10,3. And let's do that. Divided by 5.9, multiplied by 10.3, and we get an answer of 13,966 people. And our answer over here is 13,966 people. Let's just quickly do a little bit of a logic check. If 5.9% was 8,000 people, and we are increasing to go up to 10.3%, we need not quite double, just a little bit less than double. And what is double of 8,000? It's 16,000, and we've gotten 13,966, which is 14,000. I think we've done a good job, and we've definitely got the correct answer. Let's move on to the next question. C. What is the percentage difference between those who had cell phones in 2001 and those who had cell phones in 2007? So let's make sure that we're looking at the right table. Household goods, correct. Cell phones, correct. And the two figures that we'll be looking at is in 2001, we have 32.3% of households having a cell phone, and in 2007 we have 72.9% of all people having cell phones. Now we get asked for the percentage difference. The percentage difference is very easy. All we have to do is say 72.9 minus 32.3, and let's quickly pop it onto our calculator. 72.9 minus 32.3, and we get an answer of 40.6%. Now our next question requires a little bit of thinking. Do you think that this percentage has increased again today? Why? Yes, I think so. Why? You could say something like cell phones are becoming cheaper and now everybody can afford them. You could say something like, I see almost everyone with a cell phone. Or you could say, so many people are getting new cell phones that they're passing their old cell phones on to their friends. This means that everyone can have a cell phone. Let's think about this. Do you think that the percentage increase would be the same as last time? I don't think so. Could we ever add 40% onto 70%? No, we'd get 110%. You can't have 110% of a population having cell phones. That would just be absurd. Let's have a look at the next question. What are the most popular goods? Why do you think this is so? Well, if we have a look over here, our most popular goods are most definitely radios. And why do you think this is so? Well, there could be a multitude of reasons. Radios are relatively cheap. Radios are easy. You don't have to have a satellite dish to plug into a TV. You don't have to get signal for it. Most places in the whole country have radio signal very easily. A third reason is that some radios, and quite a few radios, can run on batteries. So in rural areas where there's no electricity supply, you can still have a fully working radio that runs on batteries. Let's have a look at the next question. Question number 2. A recent survey looked at the households in 2 different income groups. This study determined what percentage of monthly income was spent on 3 different things: food, housing, and other requirements. The pie charts below represent the findings of the study. Let's have a look at these pie charts. Spending by a household in Group 1, their average monthly income was 3,000 Rand per month. I'll write this a bit bigger. 3,000 Rand per month. And our second pie chart over here looks at Group 2, which has an average of 20,000 Rand per month. So as you can see, this group of people doesn't earn a lot of money at all, and this group of people has quite a lot of money to use. First of all, we ask, what were the monthly incomes of the groups considered? Well, this is easy. Group 1 had 3,000 Rand per month, and Group 2 had 20,000 Rand per month. Then we get asked what percentage of Group 1's earning was spent on housing. Now let's have a look here. We get told that food is 55%, other is 20%. Now we know that a pie chart always represents 100%, and in this case it's 100% of the salary. So in order to find out what percentage is spent in housing, we can say, well, the whole pie is 100, we're minusing 55 for food, we're minusing 20 for other, and if you're lazy, you can use your calculator to say 100 minus 55 minus 20, and we should get 25. And I hope you don't leave your answer just as 25, because who knows, it could be 25 Rand, but in actual fact, it's 25%. They're asking us for percentage. Question C. How much was spent on housing by a household in Group 2? So over here, we're looking at Group 2, we're looking at housing, and it tells us that housing takes up 40% of the monthly income. So all we have to do is say 40%, and we need to say 40 over 100 to convert it to a percentage of our monthly income, which is 20,000 Rand. Let's pop it onto our calculator. 40 over 100, don't forget to push the arrow to the side to get out of your fraction, multiplied by 20,000, and the answer is 8,000 Rand. So Group 2 spends 8,000 Rand per month on housing. D. Which group spent the larger amount of money on food? Justify your answer using calculations. Now if we have a look at our pie chart, we might think, oh, the answer is simple. This household spends 55% on food, and this household only spends 14% of food. But let's calculate to make sure. Somehow I don't think that this household spends more money on food. Let's make sure. Well, for Group 1, we spend 55%. 55% of a total amount of 3,000 Rand in monthly income. So let's find our percentage. 55 over 100 of 3,000 Rand, and our answer is 1,650 Rand per month. Let's have a look at Group 2. Go back to our pie chart. They spend 14% of a total of 20,000 Rand per month. So we have 14% of 20,000 Rand. Let's pop it in our calculator and see what we get. 14 over 100, the next arrow multiplied by 20,000, and we get 2,800. So as you can see, grade 11s, even though Group 1 spends a larger percentage of their income on food, the actual amount that comes out is far less than the amount Group 2 spends on their food. They spend a smaller percentage, but because it's a smaller percentage of a much larger amount, the amount at the end of the day that they spend on food is more. So if you want to say, finally, who spends the larger amount of money, you can say Group 2 spends more on food. Let's now have a look at question number 3. Question number 3 is looking at the ins and outs of a mountain bike race. This mountain bike race was held in KwaZulu-Natal, where it was sponsored by a big syrup company. Now, in KwaZulu-Natal, there's lots of sugarcane fields, and that's where the syrup gets made. Everyone who entered received a t-shirt and a tin of syrup. Yum! The bar graph below shows the number of males and females that finished the race in 2 different time intervals. So let's have a look here. This is showing the distribution of finishing times of males and females. First of all, we have sub 2 hours. This means that they finished the race in less than 2 hours. And over here, we have a little crocodile sign which says greater than 2 hours. This means that everyone who finished over here ran the race in more than 2 hours. And let's make sure that we know what the key is telling us. The light blue is for females and the stripes are for males. So let's just have a look over here. As you can see, there were far more males that completed the race than females. And our first question asks, explain why it is not possible to use this information to make a decision about whether or not females or males performed better in the race. Let's have a look at our bar graph again. Can we compare if there are far more males than females? Not really. So I think that can be our answer. We can say here, there are many more males than females. And therefore it is very difficult to compare. But if we had to compare, number 2 says, use any method to determine whether or not, as a group, the females or males performed better in the race. Presume that everyone who started the race did indeed complete the race. So let's go back here and see. We've got 19 plus 61 females. And for males, we've got 45 and 413. So first of all, let us find a total amount of females who entered and a total amount of males that entered. And obviously, if we want to see who performed better, I think that we should find out what percentage of the group came under 2 hours and what percentage of the group came over 2 hours. If we have a larger percentage of females finishing under 2 hours, we can say that the females did better. If we have a larger percentage of males finishing under 2 hours, we can say that they did better. So let's have a look. First of all, I'm going to do all my females first, and let's do them in green. In total, we have 19 plus 61, which is 80. So we had a total of 80 females participating. Let's see what percentage of these females finished under 2 hours. So let's work out our percentage, and we can say, well, 19 out of 80 females finished under 2 hours. Turn it into a percentage, and let's see what we get. Times by 100, and we get that, wow, 23.75 females finished under 2 hours. Now let's have a look at the males. For males, let's find, oopsie, I've said here mates, I meant males. Let's find out the total amount of males. 45 plus 413. And we get a total of 458. Now we want to find out what percentage of these males finished under 2 hours. So we see that over here, 45 males finished under 2 hours. So we're going to say 45 out of a total of 458. We multiply it by 100 to get a percent. Let's pop it into our calculator. 45 out of 458 multiplied by 100, and we get 9.8%. So only 9.8% of all the males who entered the race came in under 2 hours. I don't know about you, but that makes me think that the females did a lot better than the guys this time. That's my way of working this out. Let's have a look at the next one. Were the organizers of the race financially successful? Use calculations to explain your answer. Wow. Well, here is our expenditure and income incurred in the mountain bike race. As you can see over here, our double bar graph shows expenditure items, all of these in blue, and income items are striped. So as you can see, for income we had a sponsorship and we had the entry fees. Each runner has to pay a fee. But the expenditure looks like quite a lot. Rental of field and clubhouse, marquee, start banner, payment for DJ, music is very important when you're running, drinks, fencing for start and finish, and payment for a security company. So as you can see, there are many smaller expenditure items, but our income items are quite large. Let's see if they were financially successful. Right, so first of all, let's work out our expenditure. We've got 18,000 Rand plus 14,000 Rand plus 2,000 Rand plus 3,500 plus 4,800 plus 6,000, and I'm going to have to go a line down, plus 5,200. And let's add them all up and see what we get. We have 18,000 plus 14,000 plus 2,000 plus 3,500. Let's make sure I got that right. And 4,800 plus 6,000 plus 5,200. And at the end of the day, we get 53,500. And that is our expenditure. Now let's have a look at our income. And over here, we've only got two sources of income, 15,000 Rand and 30 something, 32,280. And we can add them up. $32,280, and together we get 47,280. And that is our income. Now, to see if we are financially successful or not, we have to say, well, our income minus our expenditure, and see if we get a positive amount, our income is more than our expenditure. If we've gotten a negative amount, it means that we've spent more than we've gotten in. So let's have a look. 53,500 minus 47,280 minus 47,280, and our answer is 6,220. I think I've done that the wrong way around. I have taken my expenditure and minus my income. I should have done it the other way around. Let's try that again. 47,280 minus 53,500. Let's try that again. 47,280 minus 53,500. And if you have a look over here, we get a negative answer. So we get equals negative 6,000. Let me make sure I get this right. 220. That means that they are short by 6,220. They've overspent. The entry fee, I'm now looking at question number 2. The entry fee for the race was 60 Rand per person. How many people needed to enter the race in order for the race organizers to break even? Now, break even means that our income and our expenditure are the same, right? So the organizers need an extra 6,220. So let's see how many extra entries they need, and then we'll see how many entries that they got, and we'll add those together. So the extra entries that they need will be an amount of 6,220 divided by 60. Why are we dividing by 60? Well, each person had to pay in 60 Rand. So if we need 6,220, we divide it by 60 to see how many extra entries we should have had. And we get an answer of 103,6. And since you can't have half a person entering, we're going to round this up to 104. So we got over here 103,6, etc. But since you can't have a half a person, we're going to make that an extra 104 entries. Now we aren't done, because they asked us how many people needed to enter the race. We've decided that we need 104 more than they already are. So now let's see how many entries there were in the first place. So let's go back over here, and we're going to be looking at this column over here. We get told that we got 32,280 Rand from entry fees. How many people does this translate into? Let's see. 32,280. Let me make sure that I got that right. 32,280. And we are once again going to divide this by 60 to see how many entries there were in the first place. 32,280 divided by 60. And as you can see, there are 538 entries. So now let's see how many entries we need in total for the race to break even. We're going to say 538 added to our for extra entries that we need, and let's work it out. 538 added to 104, and we get 642. So for our race to be able to break even, we need 642 entries, and preferably more, because I'm sure that the organizers of the race would want to make a bit of a profit. Let's have a look now at question number 4. We're looking at another compound bar graph, and it shows over here the percentage of South African children from age 7 to 13 enrolled in a primary school during 1996 and 2007. Use the graph to answer the questions that follow. Well, let's first of all look at our bar graph. All the bars in blue represent the data that comes from 1996. All the bars in grey represent the data that comes from 2007. And over here, our different categories going from smaller to bigger show what percentage of children in the whole of South Africa go to primary school. As we can see, from 7 years old, from 8 years old, 9, 10, 11, all the way up until 13. And by the time we get to 13 years old, we should expect that all children aged 13 will be in school. But unfortunately, that's not quite the case in South Africa. Let's look at the questions. What percentage of the 9-year-olds was enrolled during 1996? So let's have a look over here. We're looking at 1996, and we're looking at 9 years old. This is very easy. All we have to do is read the value of our bar graph, and we know that 87.9% of all 9-year-olds in South Africa were enrolled in a primary school. Our next question asks us to calculate the percentage increase in the enrollment of 10-year-olds from 1996 to 2007. Now, a percentage increase is very difficult to calculate. We have to make sure that we get the right numbers in the right place. And I always work out percentage change, which can be percentage increase or decrease, as the difference in percentages divided by the original percentage. So let's take a crack and see if we can do it. So we're looking at 10-year-olds, which is this over here, and we're looking at the percentage change or the percentage increase from 1996, which is 91.3%, to 2007, which is 96.3%. So let's put it into our formula. Our percentage change is going to be the difference. Now the difference is 96.3 minus 91.3 over our original value, and our original value is the starting value, which was 91.3. Let's see. For our calculator, we're going to say 96.3 minus 91.3, get an answer. So our percentage change was exactly 5%, and we divided by our original, which was 91.3, and we get 0.054. Now that seems like a little bit of an unrealistic answer. I've forgotten something. To find a percentage change, we have to make it into a percentage. How do we make it into a percentage? Multiply by 100. So let's take our answer, multiply it by 100, and our percentage change was 5.6%. 5.47%. Have we done it correctly? They've just asked us for the percentage increase. They didn't ask us to how many decimal places to put the answer into, but I like to keep my answer to 2 decimal places. Let's make sure we've done our decimal correctly. Oh no, because our third decimal place is 6, we should be rounding up. So our answer should be 5.48. Oops, 8%. I hope everyone's clear with that. Let's look at the next question. Which age group had, number 1, the largest percentage enrollment during 1996? Now, we could compare which of the towers for 1996, and that's the blue ones, is the highest. But because some of these are very close in the end, we can look at figures. Our largest for 1996 would be this one over here, 94.8, and that is the 13-year-olds. Number 2, the smallest percentage enrollment during 2007. Now we go to our grey blocks, 2007. Now if we look at the tops of these towers, they're very close, so let's rather compare the percentages, and we're looking for the smallest percentage, and it's over here, 94.8, and that is the 7-year-olds. And number 3, the greatest increase in percentage between 1996 and 2007. Let's go back and let's take these pink lines away, and we're looking for the largest increase from 1996 to 2007. This is where double bar graphs come in really handy, because all we have to do is look for the greatest gap between the 2 bars, and we know that that is the largest increase. And it can be confirmed by numbers, 73% all the way up to almost 95%. That's most definitely the largest increase. And once again, it is the 7-year-olds that have the largest increase between 1996 and 2007. Question D. If there were 240,000 10-year-olds in South Africa in 1996, calculate the number of 10-year-olds enrolled in primary school. Right, so we are looking at 10-year-olds, and we are looking at our 1996 figure. We get asked, basically, for 91.3% of 240,000. Because we get told that there are 240,000 kids who are 10 in the whole of South Africa, 91.3% of these are enrolled in school. How many is the actual number that is enrolled in school? So let's say we're going to get do 91.3 over 100 of 240,000. Now, I know you're not meant to put a decimal into a fraction, but we need to divide by 100 to make it into a percentage. So we can say 91.3 divided by 100 to get it into a decimal. And we are going to multiply this by 240,000 to see how many kids were enrolled who are 10 years old into school. And our answer is 219,120. (219,120) 10-year-olds in 1996 went to school. Right, now that we've done a couple of examples, let's go through a few of the exercise questions and let's see what hints and tips that I can give you so that you'll be able to complete these correctly. Our first question gives us a table with a whole lot of values, and it's talking about the amount of vehicles that pass through Pietersville. Let's have a look at our question. The traffic department at Pietersville, which is a town between Johannesburg and Durban along Route 48, has monitored the number of vehicles travelling through their town over a 1-year period. The following figures were issued. So the year in question obviously is 2007, and they've monitored the amount of vehicles that pass through each month. So month by month, they have told us the amount of vehicles that pass through Pietersville. If we go down and look at our pie chart, it shows the types of vehicles that have been going through Pietersville. And for this particular pie chart, they are showing us the numbers for December. So let's have a look what we've got. We've got cars, we've got minibuses, otherwise known as taxis, we've got trucks, we've got motorbikes, and other vehicles, which might be something like a tractor or something else unconventional. Let's look at our first question. Calculate how many trucks passed through Pietersville in December. Now we're going to have to look at two pieces of information from what we've been given. First of all, we want to look at the amount or the percentage of trucks that we get, and we see from our pie chart that 11% of the total vehicles that pass through are trucks. So that's our first piece of information, is 11%. The next piece of information is from our table over here, and we get told that we're looking at December. So if we look here in our table, we see that 2,255,600 vehicles passed through Pietersville in this particular December in 2011. So to calculate how many trucks passed through Pietersville in December, we need to take, and let me rub this out, we need to take 11% of 2,255,600. And I'm going to leave the answer for you to calculate. Don't forget, using your calculator is the easiest way to do this. Let's have a look at our next question. If you had been asked to draw the pie chart above, how many degrees would you have made the sector that represents the trucks? Show your working to substantiate your answer. Round your answer to the nearest whole degree. So we don't want anything like 47,2 degrees. We want the nearest whole degree. Now let's make sure that we know exactly how to work out a pie chart. So first of all, let's draw a circle. Over here we have a circle, and I'm sure, as all of us know, a circle is made out of 360 degrees. Now that's very important when drawing pie charts, especially when we get asked how many degrees our truck section would be. Now, hopefully, going back to grade 9, we know that if we go through half a circle, it's 180 degrees. If we go through a quarter of a circle, it is 90 degrees. And let's go back and have a look over here. Well, our truck section is less than a quarter of a circle, so our answer should be less than 90 degrees. And in fact, it looks like it's even just less than an eighth of a circle, and an eighth of a circle is half of a quarter, which is half of 90, so an eighth of a circle would give us 45 degrees. So logically in our minds, we know that if we want to work out how many degrees we're going to be using for our truck section, we're going to be using probably less than 45 degrees, because it looks like it's just less than an eighth of a circle, or half of a quarter. So now that we know that a circle has got 360 degrees, and we know that we're going to expect an answer of less than 45 degrees, we need to know, well, how are we going to calculate how many degrees our truck section is going to take up. Now let's go back up here and look. We get told that the trucks take up 11% of all vehicles that pass through Pietersville in December. So this 11% is a very important number to remember. Let's go over here. Trucks are 11%. Now, if we're finding a percentage, we also know that it is 11 out of 100. And to be able to convert something from 100, which is a percentage, showing the whole thing, into degrees, which is 360, we need to find our percentage and multiply it by 360, because this is the percentage, and we want to know, well, what is 11% of 360? And that will tell us how many degrees our slice of the pie is for trucks. So just so we know, let me quickly help you do it and punch it into the calculator, but I'm not going to press equals, so you know how to do it yourself. We want 11 over 100 of 360 degrees, and I'll leave it for you to calculate. Don't forget that when you get your answer, we have been told specifically to round our answer to the nearest whole degree. I don't want to see any decimals in your answer. Let's have a look at our next question. The next question asks us to draw a double bar graph. It says here on the axes provided, so let's draw some axes. Over there for us, and let's read the question through. On the axes provided, draw a double bar graph showing the differences between the number of vehicles in 2007 and 2008 that travelled through Pietersville for the first 6 months of each year. Use the figures in the table above that have been rounded to the nearest 100,000. Remember to label your graph carefully, including the axes. So our first step is to give our graph a nice heading. And you can choose something, but I would choose something like bar graph showing a comparison, because that's what we're doing. In the number of vehicles and what are we comparing? The number of vehicles in the first 6 months of 2007 and 2008. So a bar graph showing a comparison in the number of vehicles in the first 6 months of 2007 and 2008. Now that heading is quite a mouthful, but it describes very accurately exactly what we're comparing. The number of vehicles between 2007 and 2008 for the first 6 months. Let's now label our axes. At the bottom of our graph, we are going to label our months. We're going to have January, Feb, March, April, May, and June. Let's make sure that we've got 6. 1, 2, 3, 4, 5, 6. Perfect. And on the side, our axis on the side, it is going to be over here. Let's make sure we've got it. The number of vehicles traveling through the town over a 1-year period. So we can say here, number of vehicles passing through Petrusville. Now, the other important thing that we need to do is make sure that we've got a key. We need to know which is going to be 2007 and which is going to be 2008. So I suggest that you choose two different colors. We can say, let's choose green for 2007. And what other color do I have with a straight line? White. We've got for 2008. I'm going to do a few with you and then leave you to complete the rest of your bar graph by yourself. So let's first of all look at January 2007. Now remember, in the question we've been told to look at the values which are rounded to the nearest 100,000. And over here in 2008 we've also got values rounded to the nearest 200,000, and this question has very cleverly only given us the first 6 months of each, so that we only use those values. Now let's decide what scale are we going to use on our vertical axis. The numbers go all the way from our lowest number over here, 100,000, to our highest number in 2007, 2,100,000. And let's have a look. In 2008, our lowest value is also 100,000, and the highest value is just a little bit less than January. It's 2 million. Now let's go back down to our axes and fill in our scale. At the bottom, we'll start at 0. And because our highest number is 2,100,000, we can make our highest number 2 million, and we know that just higher than 2 million is 2,100,000. And I know that you all know that this is our label for this axis, but I'm going to get rid of it for now so we can put in the numbers. Halfway between 0 and 2 million will give me 1 million. And over here we've got 1.5 million, and over here we will have 500,000. And I'm sure we'll be able to work out everything in between. Now let's go back to our table and see what we can fill in for January. I'm going to put a little mark over here because I know that January is going to be in 2007 and then in 2008. So 2007 in the green. For January we've got 2,100,000. So let's go in the green all the way up to just over 2 million, 2,100,000. And there we go. So this over here is, as you can see in green, it is 2007. Now let's fill in our value for 2008. And we're going to be in the white. Let's see what we've got. Our value for January in 2008 is exactly 2 million. So our bar is going to be right over there, 2 million. And let's complete it like that. How's that for January? We've got our two values, the green for 2007 and the white for 2008. Let's have a look at February. Let's make a little halfway line, first for 2007, second for 2008, and let's go to our values. And for February, we've got 400,000 and 300,000. Let's see if we can do that one after each other. First of all, February 2007, 400,000 will be just less than 500,000. Oops, it's a little bit skinny. There we go. And in the white, we've got February 2008 at 300,000, which is just less than 400,000. And there we've got our second bar. Don't forget that our two bars comparing 2007 and 2008 need to be touching for January, but then you must leave a little gap in between as a space to show that we're now on February. 2007 and 2008 touching, and then we'll leave a little gap and go on to March. Now I'm not going to complete the bar graph for you, I'll leave that up to you, but this should give you a pretty good idea of what you need to be doing. And let's make sure, go back to the question, have we done everything? Remember to label your graph. We've done so, including the axes. And I know we've rubbed off our label here, but we have labeled our axes. Ooh, we didn't label this axis over here. We need to say here, months over 2007 and 2008. Well, there's our label for the bottom axis. Let's make sure, have we done it for the first 6 months? Absolutely. Use the figures in the table that have been rounded. We've done that, and we've labeled our graph, including the axes. Right, let's see what we need to do on the second part of the question. We are now asked to explain the trend that you notice in your bar graph. Give a possible reason for this. Well, since I haven't completed the bar graph, I can't give a definite answer for this, but I know that you will have completed your bar graph and you will be able to show a trend. Is your trend getting smaller? Is your trend getting bigger? Are there more cars in 2007 or are there more cars in 2008? And you need to come up with a reason for this. What do you think? Maybe you realized that in 2008 that was when the economy crashed. Less people were traveling, so therefore there were fewer cars on the road. Or you might have seen that there are more cars in 2008. A reason for this might be, well, 2008 comes after 2007, the population of cars has grown, and therefore more people will be driving. You might also want to predict or explain a trend that you see during the months. Are there more cars in January? Or are there more cars in May? You might see a spike of cars in April, and what does that mean? Everyone's going down to Durban for the Easter holidays. You come up with an idea and explain it, and that'll be a very good reason for explaining your trends. Let's have a look now at question 2. Question 2 is all about a company that wants to show how it is growing and what its earnings are. So it says over here, Bathwiz is a company that installs and renovates bathrooms. The general manager had to present the company's earning for the first 3 quarters of the year to the company's directors. He drew the 2 graphs below. Use these graphs to answer the questions as follows. Well, first of all, let's have a look at these graphs. Are they very different, or are they showing the same thing? So it has the same headings, Bathwiz's quarterly income, and the same over here. And it shows income on our vertical axis, and it shows which quarter we're looking at. First quarter, second quarter, and third quarter. So obviously they're just over 3 quarters of the way into the year, and he now wants to show his company's directors what's going on. Just to let you know, if you have a look very carefully at this heading, it says the income, and it says here in brackets in an amount of 100,000 Rand. So this over here doesn't mean 1 Rand, it means 1 times 100,000. So this value over here would be 100,000. 2 times 100,000, 200,000. 300,000, 400,000, and 500,000. Many people do this on graphs because there isn't always enough space to write out big numbers such as 100,000, 200,000. So it is much easier then to put a little bracket in to say that our income is in a value of 100,000. First of all, let's have a look at this question. What possible trend do you notice with regard to Bathwiz's quarterly income? And this is a very easy question. I'm sure you've already figured it out, that after each quarter, the income is increasing. Then we get asked to calculate the average, or in other words, the mean monthly income for Bathwiz for the first 9 months of the financial year. Now, I'm not going to do this for you, but I'm going to give you a couple of hints and tips. Firstly, we need to realize that 1/4 is equal to 3 months, because a year is made out of 12 months. 12 months divided by 4 is 3 months. If we are looking at 3/4, we're looking at 3 months plus another 3 months plus another 3 months. So we are looking at a total of 9 months for this question. Then, in order to find our mean, what do we need to do? We need to find our total and divide it by the number of months that it's spread over. So even though our income is given in quarters, we know that this is for 3 months, this income is for a 3-month period, and this income over here is for a 3-month period. So we need to work out this. Is that 3 rand? No, it is 300,000 rand. So first of all, let us work out our total income. And let me do this a little bit better. Let's work out our total income over the 3/4. It's going to be 3, which is in actual fact 300,000. Plus, let's have a look at our income for the 2nd quarter. It is halfway between 3 and 4, so it is 350,000. And let's look at our income for the 4th quarter. It is halfway between 4 and 5, so it is 450,000. Once we get this answer for our total, all we need to do is find our total and divide it over 9 months, because we are looking for the average over a monthly period and not over a quarterly period. So we will then find out our average monthly income by dividing by 9. I'm going to leave you to complete it. For C, we're looking at our general manager, and as you can see, and as I said earlier, these two graphs actually show the same thing, although they look a little bit different. Why do they look different? It's got to do with the scale on this side. But let's read the question first and see what we're being asked to do. The general manager wanted to prove to the company directors that Bathwiz's income was increasing and that the company was doing really well. Which graph would be better to show the company's directors? Give a reason for your answer. Let's have a look at the graphs to see what these graphs are telling us. In actual fact, they're telling us the same thing, because have a look here. For our 1st quarter, we've got 300,000, and for our 1st quarter, 300,000. 2nd quarter, 350,000 and 350,000. And for our 3rd quarter, 450,000 and 450,000. So if these two graphs have exactly the same information, why do they look slightly different? And the answer is here in the scale of our income. For this one over here, we go from 1 all the way up to 5. Whereas in this one over here, we go from 2.5 all the way up to 5. So essentially, this graph over here is taking a magnifying glass to this section of our graph. So imagine this being expanded to that. All right? So they're showing the exact same information. This one is cheating a little bit though, because it's starting at 2.5. It's only starting over here, which makes this look like a much bigger increase than that, because we've cut off this part of the graph. So let's answer our question. Which one would be better to show the company's directors? Well, I think we can all agree that graph number 2 would be better because it makes it seem like the increase in income is getting bigger and bigger, whereas in actual fact, this graph is a little bit more of an accurate representation as the income is increasing, but it isn't zoomed in on, if I could say it that way. And you can give a reason. I'm sure your reasons will be very similar to mine. Try to explain that the scale on our vertical axis has been changed. Right, grade 11s, I hope you've learned a lot today, and I hope you are ready to tackle graphs in your exams. Don't forget to study hard and go through these notes once more to make sure you've got it. Goodbye.